Hey guys, welcome back. I hope you guys had an awesome turkey week. Gobble gobble gobble. And if you didn't, well, I apologize. I hope that you're safe. I hope your family's safe, and I hope that you're doing well. All right, guys, let's go over this exam. This is the exam overview. So this was taken right before the Thanksgiving break, and hopefully after we go through this, you'll be caught up. Maybe you haven't done math the entire week. Excuse me, and that's fine. All right, let's get right into it, guys. Number one, letter A. It says find the period, amplitude, phase displacement, sinusoidal axis location, and it was worth 1 point. So the period is 2 pi. This is your B right here. So the period is, you can say 2 pi divided by your B, or you can just multiply. You see the pi there, so you can say the period is 10. Or, if you don't see that, relax. Just 2 pi divided by pi over 5, which is 2 pi times 5 over pi. The pi's cancel out and you get 10. So the period is 10. Period is 10. And then the amplitude is the number in front of the cosine. So the amplitude is 7. And then your phase displacement is that number right there. It's 3 to the right with respect to cosine. 3 to right. To the right. And then the sinusoidal axis location, you could also call it the midline. The midline is 4. And then it says sketch a graph. So here's the y-axis, here's the x-axis. I guess let me put the x-axis lower. The midline was 4, so I'm going to say that this is 4 right here. And then the amplitude is 7, so 7 plus 4 is 11. So I'm going to say 11's up here. And I'm going to go that same distance down. So what's that, -3? So I'm trying to be consistent with these gaps here. They may not be perfect, and that's fine. So 3 to the right. So here I'm going to say that's 3. I have a max. And then every 10 I have every 10 I have another max. So that's going to be at 13. So at 13 I have another max. So I'm going to see if I can keep it the same gap. And I can hear that my phone's ringing, but I'm not going to answer it at the moment. All right, and in between the 3 and the 13, so like at 8, that's right, 3 plus 8, 3 plus 5 is 8. You have a min. And then at 18, you have another min. And it would be nice if you put those there. If not, no big deal. And then between your high and your low, you have a point of inflection. And between your low and your high, you have another point of inflection. And between your high and low, you have a point of inflection. And low and high, another point of inflection. And it's not perfect. I can see that it's not super perfect. And it doesn't have to be. But at least try to make, more or less, at least have the maximums where they're supposed to be and the minimums where they're supposed to be for a cosine graph. And there it is, guys. Yeah, there it is. That's full credit right there. Here we go. Find the period, amplitude, phase displacement, sinusoidal axis location. So the period is 7. You can already tell because it's 2 pi divided by that number in the bottom. So that number in the bottom is going to be your period. If you don't know what I'm talking about, well, the period is 2 pi divided by the b. The b happens to be 2 pi over 7. So the period is 7. So period is a 7. Amplitude is the number in front of the sign there. So it's 5. The midline or sinusoidal axis is a -3. And your phase displacement, you can actually say phase displacement 4 to the left, or you can say 3 to the right, because if you add 7 to -4, you'd be at 3. But that's fine. That would be, this right here is a full credit right there. And then it's funny that a lot of you told me that the phase displacement was 4, but you didn't even draw that. So that we kind of had a little issue with. I wouldn't call it an extreme issue, but a little issue. So here we go. So there's my x-axis. Let's see. The midline's at -3. I'm going to call -3 right here. That's a bad job there. So let me make it better, guys. There's my dashed line. The amplitude is 5. So I'm going to say that the distance between -3 and this number is, I'm going to say that gap is 5. -3 plus 5 is 2. So that's a 2. And the -3 minus 5 is a -8. So this is the min, and this is the max. All right, now remember, this is sine, so we need to do a point of inflection. So I'm going to say that my point of inflection, remember at -4, right there, and point of inflection, going up. And then the period is 7, so it's going up right there. So I'm going to add 7 to that, -4 plus 7, that's going to be a 3. So I'm going to say that 3 is like right here. And that's another point of inflection going up. And then I add another 7 to that, and I'm going to be at 10. So I'm going to say 10 is like right here. And another point of inflection going up. So a lot of you messed up and you put point of inflection going up, point of inflection going down, point of inflection going up. But nope, it's every 7, it's a point of inflection going up, guys. So right smack in the middle of these points of inflection going up, I have another point of inflection going down. So 7 divided by 2 is 3.5. So -4 plus 3.5 is 0.5. So right there, I have a point of inflection going down. And then -0.5. That's a -0.5, by the way. -0.5 plus 3.5 puts you at 3. So right in the smack in the middle. And I don't necessarily have to see those guys. It would be nice. So where are the maximums? I don't know exactly where they're at. I just know they're in the middle there somewhere. Where's the minimum? I'm not going to calculate those. What I did want to see, I wanted to see that, I wanted to see that, and I wanted to see that. If you showed me this one, then that was great. If you didn't, what I wanted to see was the points of inflection, guys. And some of you did not show me that. And as you can see here, this graph is, I mean, I wouldn't call it the best graph, but it'll work for now. And I don't know if you can hear the music in the background. I have the music playing ever so lightly. And there it is, guys. All right, let's see. Let's keep going. Oh, what did I just do there? Did I just move a line accidentally? What was that line at down here? All right. Question 3. Find a particular equation for the sinusoid. All right, so let's do that first. I have a max at -13. I have a min at -2. A lot of you gave me a negative vertical dilation, which is fine. I just thought it was a little odd, but that was fine. I don't know. Maybe there's an app that puts negative vertical dilation all the time. So here we go. First thing I would do is probably find the period. So the period, let's see, from -3 to -2, that's a distance of 11. And that's a max, that's a min. You've done 50% of a cycle. So that means the period has to be 22. And then from there, the amplitude, well, let's see, I have a max at 3, and I have a min at -7. So I guess let's find the midline first. So the midline is going to be 3 plus a -7 divided by 2. So that's -4 divided by 2, excuse me, which is -2. So the midline's a -2. Now the distance from -2 to 3 is 5. So that means the amplitude has to be 5. And sure enough, the distance from -2 to -7 is also 5, guys. So let's see, what else do I need? I guess I need my B. The B is, this is in radians, so 2 pi divided by the period, 22. So that's going to be pi over 11. And I guess if I'm using the peak, I can either use this one or I can use this one if you wanted to count. I believe that happens at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's at 9 there. So it doesn't matter which one. It could be any of these here. So for letter A, you could say y equals 5 cosine pi over 11 x minus 9 close minus 2. You could also say y equals 5 cosine pi over 11 x plus 13 close minus 2. And the one that was very popular, surprisingly, was -5, and then you guys use the -2 there. So -5 cosine pi over 11 x plus 2 close minus 2. Any of those three would work. Could you use sine? Maybe you could use sine, but I don't think it would be ideal, guys, because because it looks like it's going to be a little tougher to figure out that point of inflection to get that exact number. But we have a max, we have a min, so I think it's easier to just use cosine. And then letter B wants you to solve this algebraically. So you can use any of those three formulas. It does not matter which one. I'm going to use the one in the top, guys. It wants us to solve when this function equals -4. So I'm just going to use this one, the very first one. So I'm going to write 5 cosine pi over 11 x minus 9 close minus 2 equals negative 4. And then all you're doing here, guys, is just solving for x, right? So to solve for x, first you add 2, so add 2. And then you have 5 cosine pi over 11 x minus 9 close equals negative 2. And then you got to get rid of that 5 because you can't solve for x right now at this moment. Divide by 5, divide by 5. So then you have cosine pi over 11 x minus 9 close equals a negative 2/5. And then you get rid of that cosine by doing inverse cosine. So you're going to have pi over 11 x minus 9 close equals plus minus arc cosine of negative 2/5 plus 2 pi n. And then from there, you want to get rid of that pi over 11 in the front. So I'm going to multiply by the reciprocal. So you multiply this by 11 over pi. And whatever you do to one side, you do to the other. 11 over pi. So here we go. When you distribute that, you're going to get x minus 9 equals. Put that here in the front. Oops. And I didn't want to write in green. I wanted to write all this in red. X minus 9 equals plus minus 11 over pi. Some of you guys miss this step algebraically and eventually put it back in there, but just put it in there from the beginning, guys, because that's an algebraic mistake, right? Pi's cancel out. That's 22n. That should not be a surprise. That right there is your period. So then I'm just going to do the last step here. It's just going to add 9. So 9 plus or minus 11 over pi arc cosine of negative 2/5 plus 22n. And I'm going to get a calculator. And I'm going to figure out both equations. I'm going to come up here, and I'm going to write x1, and I'm going to write 9 plus 11 over pi arc cosine of negative 2/5 plus 22n. And I'm going to write what this statement is, what these two together are. And so let's find out what that is right now. So I'm going to go to Desmos. So let me go to Desmos real quick. I don't need a graphing calculator. I just need a scientific calculator. So scientific, and here we go. I am in radian mode, so I go to radian, and I go 9 plus, and then I need arc cosine, and what was it, a negative 2/5? So negative 2/5, and there it is. So I push enter. 10 point, oh, I forgot the 11 over pi. I know, some of you guys are screaming. 11 over pi. There we go. Arc cosine, negative 2/5. I'm in radian mode. All right, so there it is. 15.941, always 3 digits. So I'm going to go back to this guy. So I think it was, let's see if I remember, 15.941 plus 22n. And then for x2, the second one, instead of a plus, I'm going to do a minus. Because remember, there said plus minus there, right? So I'm going to write 9 minus 11 over pi, arc cosine of negative 2/5 plus 22n. So x2 is, so I'm just going to go back to Desmos, and I'm just going to change that plus to a minus. And it really is that simple, guys. So now I got 2.05. So 2.0591. So 2.059. 3 digits always, unless otherwise told. All right. 2.059 plus 22n. These are my general equations. I still don't have my answers. So what answers do I want? I want these. Wherever you see those red dots, you can see. So this number, that number, that number. Oh, I was way off in this drawing. But yeah, I want all those values, all those x values. I guess to put little arrows on them. All right, so let's find those x values, guys. So let's see which ones I already have. I'm going to write x equals, and it looks like I have the 2.059. So it looks like I'm going to put a check mark, a green check mark on the ones that I already have. This looks like 2.059. So I have this one, or I'm going to circle it. And I have the 15.941. Oh, so let's see where that one's at. 9, 10, 11, 12, 13, 14, 15. I got this one. So these are the ones I have. Check mark, check mark. So I am missing 1, 2 to the left of the 2.059, and one to the right of the 15 point whatever. So there it is. Now I know I'm going to leave some space then. So let me leave some space. 1, comma, 2, comma, and then I'm going to write 2.059, comma, 15.941, comma, and I need one more. All right, so let's start. I have the 15.941 right now in my calculator. No, the 2.059. So I'm going to go ahead and add. So if I take the 2.059, let's see, and I add 22 to it, I'm going to get the one way over here. And that's easy to do, guys. 22 plus 2, that's just 24, right? So that's going to be, my last one is going to be 24.059. I just got that from this, adding 22. So now I'm going to subtract 22 from the 2.059, and that's going to give me that one. See? So you can see it visually here. If I take this number here and I subtract 22, you're going to get this one way over here on the left-hand side. It looks like almost negative 20. 13, 14, 15, 16, 17, 18, 19, 20. Almost negative 20. Not quite, but it looks really close. So let's see what that number is. So there it is. I got this number, and I'm just down here. I'm just going to go, you know what? I can probably just do it up there. Minus 22. Negative 19.941. So that's what I'm going to put. Oh, that's my editing software there. Negative 19.941. Okay, I got that one. So now I'm just missing one more. And I'm going to get that one more from the 15.941, which is this one right there. And I'm going to subtract 22, which will give me this one right here in red that I'm circling. So let's find that last one. I'm going to go back to Desmos, and I'm just going to change that minus to a plus because I remember that gave me that 15 there. And there it is, negative 6.059. And maybe I did a little harder, guys. Maybe I would have called one A and one B, but you guys get the idea. Negative 6.059. Negative 6.059. Okay, so let me write that down. Negative 6.059. And there it is. Those are all my answers. All of these. 1, 2, 3, 4, 5. There's 5 of them. All right, let's keep going. This one says, the figure to the right shows the depth of the water at a point near the shores as it varies due to tides. A particular equation relating D in feet to T in hours after midnight on a given day is given by this equation. The 3 is the midline, the 2 is the amplitude, and it says, find a time at which the water is deepest. Well, they give us cosine, so you don't really need a calculator, but if you put one in, that's fine. We're probably going to need it in a little bit. So the time is deepest. I know I have a max whenever this is a shift 4 to the right, so I know I have a max at t equals 4. So at 4 hours past midnight, I am 5 feet deep. How do I know that? 3 plus 2. At 4 hours past midnight, the water is 5 feet deep, and we can see that. Let's go ahead and plug that in, guys. All right, let me see. I'm gonna go back. I'm gonna push graphing calculator. I'm gonna push y equals 3 plus 2 cosine pi over 5.6 open x minus 4 close, and there it is. So I'm just looking at these times right here because t values are positive. So there it is, the max right there. That happens 4 hours after midnight, and the y value is the depth, so it's 5 feet deep. All right, after the time you found in part A, when is the water next at its shallowest? Okay, so that means the minimum. So I go back here, and I'm going to look for my minimum, and there it is, 9.6 hours after midnight. It is shallowest, and it is 1 foot deep. If you want to figure out what time that is in minutes, take the 0.6 and multiply by 60, and that's 36. So at 9:36 a.m., the water is shallowest. You don't have to do that. You can just say 9.6 hours. So I'm going to write Next, water is shallowest at 9.6 hours after midnight. Remember that 0.6 just means 60% of an hour, right? So if you wanted to do that, you could also say 9:36 a.m. No big deal if you didn't say that. The water is 1 foot deep. And you can also see that from the equation. 3 minus 2 is 1. Alright, now it says solve algebraically for the first positive time at which the water is exactly 4.5 feet deep. So I'm going to set this equation, this guy right here, equal to 4.5. And that's all I'm going to do. I'm just going to solve for that, guys. So I'm going to write 3 plus 2 cosine pi over 5.6, open parenthesis, t minus 4. T minus 4, close, equals 4.5. So you get a point if you just wrote that. And I'm going to subtract 3, minus 3, minus 3. So then you have 2 cosine pi 5.6, pi divided by 5.6, t minus 4, close, equals 1.5. I'm going to divide by 2. Some of you guys have a bad habit of writing a line past the equal sign. Do not do that, guys. This is a new statement, equals whatever you have on the right. So just do the same thing on both sides. So then you have cosine pi over 5.6, t minus 4, close. 1.5 over 2 is actually 3/4, guys. You could say 0.75 if you want. And then to get rid of the cosine, I'm going to do inverse cosine. So I'm going to write pi over 5.6 t minus 4 equals plus minus our cosine of 3/4 plus 2 pi n. You won't need this. Well, this is just going to be your period when you multiply by the reciprocal of the pi over 5.6. So multiply by 5.6 over pi, which is just a reciprocal. Multiply all that by 5.6 over pi. And you're going to get, so let's see, t minus 4 equals plus minus 5.6 over pi arc cosine of 3/4 plus, and then the pi's cancel out, and then 2 times 5.6, that's 11.2. And then move the 4 to the other side. So 4 plus minus 5.6 over pi arc cosine of 3/4 plus 11.2. And there should be an n there for n hours, right? Or for n cycles. I should not say n hours, n cycles. So there it is. And then we're going to see which one is the bigger one. I mean, the smaller one, sorry. We want the one that happened first. So it's probably going to be the minus one. But we'll calculate both anyways. So let's see. So let's see what this part is. So T1 equals, so 4 plus, let's see if we can remember that. So I'm going to go back. Yes, leave. I don't need a graphing calculator. I mean, you can use a graphing calculator, but you don't need it. So I'm going to put, let's see, what am I going to put? Let's see if I remember. 4 plus, and then it was 5.6 over pi. And then it was arc cosine of 3/4. You can also say 0.75. And there it is, 5.288. So I'm going to go back to this and I'll say 5.288 plus 11.2n. That's the first one. Let me see what the next one is. I'm going to, instead of add, I'm going to subtract. So I change that plus here to a minus. And there it is, guys, 2.711. So I'm going to go back and I'll say 2.711 plus 11.2n. This is just means how many cycles you've done, because 11.2 is actually the period. So what you want, it says the first positive time. So I'm going to write the water is first at 4.5 feet deep at 2.711 hours after midnight. I don't know if that makes sense there or not. So the first positive time at which a water is exactly, okay, maybe you should write it like this, guys. The first positive time at which a water is exactly 4.5 feet deep occurs at 2.711 hours after midnight. So there it is. It probably sounds better that way. The water is first 4.5 feet deep at 2.711 hours after midnight. There it is, guys. Let's keep going. Oh, this one looks like fun, guys. So this is in degree mode. I only penalized you 1 point if you put everything in radians. I didn't take away a point in every single one. So if you got them all right, but you put it in radian mode, you got 7 out of the 8. So let's go ahead and get a general equation here. Notice the very first one says it's going to be a cosine function anyways. And I should be using y and theta, but I just keep using y and x. No big deal. Let's see, I have a peak at -4 and I have another peak at 8. So the difference between -4 and 8 is 12. So the period is 12. The midline, it's very easy to see, or the sinusoidal axis, is 29. And then the amplitude, you can find the amplitude by taking the difference between 47 and 29. So 47 minus 29, so let's think about that. 29, 39, 49, that's 18. So the amplitude is 18. Let's see, what else do we need? Well, we need the B value. We're not in radians, we're in degrees. So instead of saying 2 pi, I'm going to say 360. So 360 divided by 12. Well, 12 goes into 36 3 times. 12, 24, 34, 35. Yeah. So 12 times 30 must be 360. And some of you guys put a degree on the B. Don't do that. But I didn't take away anything. But yeah, don't do that. So here we go. Let's find our equation. You can use the -4 or the +8 for the peaks. It does not matter. So I'm going to write y equals, it says cosine of the parent function was positive vertical dilation. So amplitude is 18. Cosine, open parenthesis, we said the B was 30. Open parenthesis, I should use the theta. If you use the next, no big deal. Theta plus 4. Close. I'm using the one that's closer to me. You could also say -8, no big deal. Plus 29. So there it is. Let's go to the next one. Y equals, they want a negative vertical dilation. So that just means a negative in the front. So -18. So you're going to have to use the minimum now, guys. So I'm going to look at this one right here. So -18 cosine 30 theta minus 2 close plus 29. And then the sine of the parent function with a positive vertical dilation. So I need to use a point of inflection, change it from concave up to concave down. So it's either going to be that one or this one, the one at -7 or the one at 5. Actually, you could also use this one if you want to calculate this theta value down there, which is not too hard to do if you really wanted to. So y equals 18 sine 30 theta, and let's see, well, let's use the 5 one because the 7 one is further away from the y-axis. So I'm going to write theta minus 5, close, plus 29. There it is. And now I want to use it with a vertical dilation, so I need to use one from concave up to concave down, or you can also say changing from okay, I was going to say increasing to decreasing because I was thinking of calculus for whatever reason. Changing from point of inflection, changing from concave down to concave up, or you can say decreasing from left to right. So either that one in green or this one here in green. And I hope I said it correct earlier. Concave up to concave down for the first one. For this one, concave up, concave down, concave up, concave down. Yeah. Okay, here we go. Y equals -18 sine, and then theta. We said we're gonna use. This one. So theta plus 1. And I just noticed that I did not put the 30. So let me do that again. Theta plus 1, close, plus 29. All right, guys, we're almost there. These two, here's what I needed to see. And some of you guys, I don't know, I'm not sure, guys. I needed to see a little more detail, and you guys didn't show me that. So it says solve sine x 5x sine 5 Can't even talk. Solve sine 5x equals 1 on the interval 0 to power over 2. Show all steps for full credit. All steps. So I wanted to see this. I'm doing the arc sine already. So 5x equals arc sine of 1 plus 2 pi n. You didn't necessarily have to show me that step. You could have just gone 5x equals pi over 2, like right here, plus 2 pi n. But some of you guys like circled pi over 2 and like, oh, that's one of the answers. I don't know how you got pi over 2 from here because x is not by itself yet. Divide by 5, divide by 5, divide by 5. X equals pi over 10 plus 2 pi n over 5. So here's one answer. If n is 0, semicolon, x is going to be pi over 10. That's one of them. Because if n is 0, that means this right here is 0, and it's just pi over 10 plus 0. Now, if n equals 1, so that means I've done a full cycle. If n equals 1, then what does x equal? Well, let's see. X equals pi over 10 plus a full cycle, so 2 pi over 5. I'm going to get a common denominator, so I'm going to multiply that by 2 over 2, and you get pi over 10 plus 4 pi over 10. So when you add those, you get 5 pi over 10. Now that reduces to pi over 2. So this is how you get the pi over 2. And a lot of you guys did not show me that. So there it is. Now a whole bunch of you did a whole bunch of magic with this one, guys. You guys truly lost me on some of this. So I don't know, maybe some of you guys have gotten used to just writing some gibberish and getting the correct answer and then getting credit for it. I wanted to see all your logical steps, guys. Divide by 2 both sides, so cosine. So almost everyone at least I think did this here. Cosine 5x minus pi over 4 equals the negative square root of 3 over 2. And then from there on the unit circle, negative square root of 3 over 2 happens in 2 locations. And you could have done the plus minus deal. It would have been perfectly fine. Or you could have just gone this route, 5 pi over 6 and 7 pi over 6. So from there, I'm going to write the first equation. So I'm going to write, I'm going to do inverse cosine. So I'm going to write 5x1 minus pi over 4 equals 5 pi over 6 plus 2 pi n. And I'm going to do it in green, the second one. 5x2 minus pi over 4 equals 7 pi over 6 plus 2 pi n. Alright, I'm going to go back to the red one, guys. So I'm doing this one here. So now I'm going to move the pi over 4 to the other side. So 5x1 equals pi over 4 plus 5 pi over 6 plus 2 pi n. So then 5x1 equals, so 1/4 plus 5/6. So you could do a common denominator right there, guys. You can multiply that by, or you know what, just take your calculator. 1/4 plus, you know what, it doesn't matter. 6 over 6, 4 over 4. So you get, let's see, 6 pi over 24 plus 20 pi over 24 plus 2 pi n. And then you get this, 5x1 equals 26 pi over 24 plus 2 pi n, which reduces to, let's see, 2 goes into 26 13 times, 2 goes into 24 12 times. So 5x1 equals 13 pi over 12 plus 2 pi n. We're not even done. You got to divide by 5. Divide by 5, divide by 5, divide by 5. That's a 5 there. So now you get this. x1 equals 13 pi over 12 times 5 is 60. So there's one answer. And of course, we're not going to add the 2 pi n over 5 because it'll take us outside the domain. Because that's 13 pi over 60 plus 2/5 of pi will be outside of pi over 2. So there's one answer. Now let's go back to this one in green here. So I'm going to write 5x2 equals pi over 4 plus 7 pi over 6 plus 2 pi n. So 5x2 equals, add these together. Use the calculator or find common denominator like we did. So 1/4 plus 7/6 is going to be 17 over 12. So 17 pi over 12 plus 2 pi n. And then divide by 5, divide by 5, divide by 5. x2 equals 17 pi over 60 plus 2 pi n over 5. So what are my final solutions? My final solution is that 13 pi over 60 and 17 pi over 60. A lot of you did not show me all that detail, guys. Some of you guys just stopped right here and were like, yeah, from there you can see the answer. No, I cannot. If you feel that I was unfair, come talk to me and I will make one up on the spot, and then you follow through, and then we'll stop where you stopped. And if you can explain your logic and get the correct answer the second time around, then maybe we'll give you the points back. All right, guys. I hope you guys are happy. I hope you guys are okay. Hook it up with a thumbs up if you feel it helped. I guess you could give it a thumbs down if you feel that it didn't. If you feel that it didn't help. And I'll see you guys later, guys. All right. Bye.